Hello everyone, welcome to Unlock Maths. Today we are going to discuss particular integral when we have x is equals to x raised to m into v. Here m is a positive integer and v is, this is sine of ax or cos of ax. That means here we have x is of this type. Yes, we can take examples here. X is equals to x into sine of ax, or this is x square cos of ax, or this is x cube sine of ax, and so on. Yes, here we have x is of this type, x raised to m into v. Here m is a positive integer. Now we have to find pi for this case. Now, to know the working rule for this case, first we should note down these things. We know that we have Euler's formula. This is e raised to I theta is equals to, this is cos of theta plus I times sine theta, right? So here we know that this is cos theta is a real part of this e raised to I theta, and this is sine theta is the imaginary part, right? Yes, here we have cos theta is real part and sine theta is imaginary part of this e raised to I theta. Now, yes, we will see how to proceed for this case. Yes, we know that we have formula for pi. This is 1 upon f of d into x. Now, here we have this case x raised to m into v. Yes, now if we have v is equals to, this is sine of ax, then this pi we have, yes, x raised to m into, here we have taken v as a sine of ax, right? So yes, we can write this is as sine ax. This is what? Imaginary part. So this is, yes, this is the imaginary part of e raised to iax, right? We have write down sine ax as the imaginary part of this is e raised to iax. So now, yes, we can write down this is imaginary part. Yes, we have taken this imaginary part, this is outside. So here we have operation, this is 1 upon f of d into x raised to m e raised to iax. Yes. Now we know that we can solve this is here by our previous cases, right? Yes. So when we have this is x raised to m into sine ax, we have to write down imaginary part of this. Yes. So similarly, when we have this is v is equals to cos of ax, right? So we can write down pi. Yes. So what is this cos of ax? This is cos of ax, this is real part, right? Yes, and we can take this is real part, this is outside this operation, and we have this operation here 1 upon f of d into x raised to m and this e raised to iax. Yes, yes, and we know that we can solve this is by previous cases. Yes, here we have to use this case of this x raised to m into e raised to ax, right? So yes, we have seen this case earlier and we can solve this is to find required pi. So yes, when we have sine ax, we have to take imaginary part of this operation, and when we have cos of ax, v is equals to cos of ax, we have to take this real part of this operation 1 upon f of d into x raised to m into e raised to iax. Yes, what we have done, we have written down cos of ax as a real part of this e raised to iax, and we have taken this is real part, this is outside. Now question arises, is both this are equal or not, right? Can we take this is real part, this is outside here? Yes, we can check this is by one example here. Let if we have z is equals to, this is 2 plus 3i, then 4z is equals to, yes, we have multiplied this is z by constant, so here we have, this is 8 plus 12i, right? So this is the real part and this is imaginary part of this 4z. Now we can write this is 4 into this real part of this 2 plus 3i, this is 4 into real part of this one, this is what here, real part of 2 plus 3i, this is 2, that means this is here we have 8. And similarly this is for imaginary part, right? So what is here, imaginary part of this one, this is 3, so 4 into 3 we have here 12. So yes, here we have checked that, yes, we can write in general when we have this is k in for any constant, we have, so yes, for any constant k and for any complex number or any functions of complex variable, we can write this relation, right? So yes, we have seen this, both these are the equal. So yes, for any constant we can write this here. So similarly here we have this 1 upon f of d and x raised to m, these are the terms which are free from I, right? So that means these two steps are equal, so that we can take this real part, this is outside. So yes, here we have to remember, when we have v is equals to sin ax, we have to take imaginary part of this operation, right? And when we have cos of ax, we have to take real part of this operation. Yes, so in this way we have seen what is the working rule when we have x is equals to x raised to m into v, right? This rule again get clear by some examples. We will see some examples in next lecture. So yes, that's it for now. See you in the next video. Thank you. Keep watching.